Okay, we are going to look at number 17 for the free response. Let's see what we got. So we got this table with a lot of information. The functions f and g are differentiable for all real numbers. This is important. The fact that f and g are differentiable for all real numbers, super important. And g is strictly increasing. The table above gives values of the function and their first derivative at selected values of x. The function h is given by, and this again is important, given by this. Okay, our setup is there. Let's go to letter A. Explain why there must be a value on r from 1 to 3 such that h of r equals negative 5. So first off, let's just kind of go through. So they're asking us to show that h of r equals negative 5 at some place on the interval from 1 to 3. So the first thing I need to know is what is h of 1 and h of 3. So here's going to be my thought process, and hopefully it's the first thing that jumped out in your mind. I'm going to want to use the IVT, intermediate value theorem, right? Because if I can say, hey, look, h of 1 is this, and h of 5 is this other number, and h of r is some number, negative 5 is in between those two numbers, then by IVT, there has to exist this value. So again, I'll put that together a little bit cleaner, but that's my thought process here is let's use IVT. So what do we got here? So we were given h of x equals f of g of x minus 6. Then h of 1 is going to be equal to f of g of 1. Whoa, that's not a 1. F of g of 1 minus 6. G of 1 is 2, so I can say this becomes f of 2 minus 6, and f of 2 is 9. So this becomes 9 minus 6, or 3. I'm then going to do the same thing for 3. So h of 3. Let's see what that becomes. So this becomes f of g of 3 minus 6. Ooh, kind of messy there. So let's figure out g of 3 is 4. So this becomes f of 4 minus 6, which equals f of 4 is negative 1. So this is negative 1 minus 6, which equals negative 7. Perfect. Okay, so I think you'd agree negative 5 is in between those two numbers. So now it's time to use IVT. So let's think about what are the conditions to use IVT. In order to use IVT, all I need to know is the function is continuous and that the number I'm looking for is in between those two endpoints. Okay, let's do it. And actually, I am going to type this out like I did the other day because my typing is neater than my writing. So, disappeared. So since f and g, so basically what I'm going to say is since f and g are differentiable, right? Since f and g are differentiable, they are continuous. Okay, so I've established that both the functions are differentiable. I've established that both the functions are continuous. Next, I'm going to kind of restate what I said, and that is I'm just going to say, I'm going to show that that negative 5 is in between each one. So I'm going to say h of 3 equals negative 7, which is less than or equal to negative 5, which is less than or equal to h of 1, which equals 3. So I've showed that negative 5 is in between both of those. So now I can finish this up. because I've established everything I need for intermediate value theorem. So now I can say okay. So by IVT, I've established that I can use IVT. So by IVT, there must be an R on the interval from 1 to 3 such that h of R equals -5. So reminder. And here's how I knew they were asking for an existence theorem. Because they're saying, explain why there must be. That's right. They're basically saying, how do you know this exists? Okay, so then how do we approach this? Well, we know what theorem, so we have to say, what theorem are we using? Okay, once you've decided on your theorem, you have to say, what are the conditions for my theorem? The conditions are, for the IVT, that the function is continuous and that the number I'm looking at is in between the two given numbers. If both those things are true, then I can use IVT. So notice in the first part, I said, hey, look, here's how I know the function's continuous. Then I said, hey, look, I'm showing that -5 is in between these two. So I've established the prerequisites for the IVT. Now I can say what IVT does for me. Okay, let's move on to letter B. Explain why there must be a C value, or a value for C, I'm reading it slightly wrong, from 1 to 3, such that h prime of C equals -5. Okay, so now they're asking about the derivative. So my thought is, what I'm going to do is I'm going to find the slope of the tangent line from h of 1 to h of 3. And then hopefully it's going to equal -5. And then I can say, look, by the mean value theorem. My plan is to use mean value theorem in other words. So first off, and I will do, let me just grab this. Let's grab that and we'll paste it there. Whoa. Okay. So first off, the nice thing is we've already found h of 1 and h of 3. So again, h of 1, I'm just going to summarize this for myself. H of 1 is 3. H of 3 is -7. And now I'm going to go and check and see if that slope even works. So I'm going to say, let's see, h of 3 minus h of 1 over 3 minus 1 is, so h of 3 is -7. H of 1 is 3 over 3 minus 1. So that's -10 over 2, which is, oh, look at that, perfect, -5. So the slope of the tangent line between 1 and 3 equals that number that I'm looking for. Perfect. So let's think about, before I put this down, let's think about what is required for a mean value theorem. And then what does it say? The mean value theorem says that a function has to be both continuous and differentiable. Well, we know it's continuous because we just showed it was continuous in part A. We also know it's differentiable because they told us that it was differentiable in the instructions. Then it says that if that's true, right, if those two things are true, then the slope of the tangent line between those two endpoints, there has to be a C on that interval between those two endpoints such that h, in this case, h prime of C equals the slope of that tangent line. Okay, so let's put that together in a little bit more sense here. So I'm gonna actually start with just kind of I've got this little piece. I'm gonna start putting this into words here again. So what do we got here? And I'm just gonna kind of repeat myself from last time. Again, I just literally almost repeated what I said on the first part, but I'm establishing continuity and differentiability. So what's our conclusion from MVT? So since this is differentiable and continuous, by MVT, there must exist a C such that, so this following statement has to be true. Excuse me, not F, it should be H, shouldn't it? H prime of C equals the slope of the tangent line between those 2 points. Okay, so again, I said, what do I need in order to use MVT? I showed that I met the requirements, and then I did my conclusion based on that. Let's continue. Letter C. Letter C. Let's go and grab letter C again. Okay, let W be the function given by, whoop, what happened there? Uh-oh. Whew, that scared me. Okay, let W be the function f of Wx equals that stuff. Find the value of W prime of 3. Okay, so let's start with that. So we were given W of x equals this integral. So what I'm going to do now is I'm going to take the derivative of both sides. So in other words, W prime of x equals, I think you'd agree, the derivative of this thing. So this is second fundamental theorem of calculus. So this becomes f evaluated at g of x, but we're going to be doing chain rule because g of x is a function, so times g prime of x. Next, I'm going to evaluate this at 3. So I'm going to f of g of 3 times g prime of 3. So let's continue here. F of g of 3. F of g of 3. So what is g of 3? G of 3 is 4. So g of 3 is 4. And g prime of 3, boy, this is kind of a pain, is 2. Okay, then f of 4 is -1. So this is -1 times 2, or -2. Okay, and that's all there is to it. We're just kind of following the math on that. They didn't ask for any explanation or anything. So we're good to go. Let's move on to letter D, the last one. I think I'm going to grab that table also, so I'm not like constantly moving back and forth. That's kind of awkward. So there's that, and let me grab that table too. Okay, what do we got for D? So if G inverse, so they gave us the inverse, so that is the inverse of G, write an equation for the line tangent to the graph of y equals G inverse at x equals 2. Okay, so we're being asked to find the inverse function. So let's think what we need. In order to write the equation of line, we need two things. What are the things we need? We need a point, and we need a slope. Let's start with the point. So we are supposed to take this function right here and evaluate it at 2, right? So in other words, this that highlighted green one, and I'm going to write this in green to kind of keep that what's it called? to help organize it. Help organize it. So that means this function right here, that highlighted green one, passes through the point 2 something. Okay? So it passes through the point 2 question mark. Let me make sure that question mark's a little nicer. Okay? Which means G, right? If I want to find out what that question mark is, I know that G itself, and I'll do this in, how about in purple? G is going to pass through the point question mark 2. So now I'm going to go to my table, and I'm going to say for what value of x, right? In other words, for what value of x produces 2? So I go to my table and I say, oh, look, when G is 1, x is 2. So in other words, G of 1 equals 2. So the original function, right, passes through the point 1, 2. The inverse function passes through the point, and let's do that in green, passes through the point 2, 1. Okay, we have got our point. Next, we have to find the slope. Now, I want to remind you, I know it's been a long time, so let me just do this really quickly. If I have two functions, if I have one function, and both functions are inverses of each other, so function 1, function 2, these two are inverses. If I know the slope of the tangent line to function 1, so let's say it passes through the point 1, 2. Let's say this is the point 1, 2. And I know the slope of that line, so let's say the slope of that line is like 2. Then I know the slope of the line that passes through the point 2, 1. It's going to be the reciprocal, right? So if I said 2, it's now going to be 1/2. So what I'm going to do is I'm going to say the following. I'm going to say, let's see here. I'm going to say G. So I'm going to take the inverse, the derivative of the inverse at 2, right? Because that's what we're supposed to do. But that equals, what does that equal? That equals 1 over this, right? So just make sure you understand what I did. So again, if this is the point 1, 2, right? Then in order to find the slope of that pink line, I think you'd agree, I would take G prime and evaluate it at 1. If I want to find the slope of this one, I'll do this in red, right? All I do is take whatever this number was. So I said this was equal to 2. I just flip it, right? So in other words, this slope would automatically be 1/2. And that's kind of what I'm saying there. I'm just kind of showing you. And I'm being a little more explicit, which I don't need to be. So what does that equal? So G prime of 1 is 5. So this becomes 1/5. So notice what I have now. I have both a point and a slope. So now I'm ready to write the equation of my line. So my line is y minus 1 equals 1/5 x minus 2. And then let's see. Let's see if I can leave it like this or I have to solve it for y. So write an equation of the line tangent to the graph of y equals this. Now they didn't ask to solve it any further. So I can leave it like this, or if I want to solve it for y, I can add 1 to both sides. Well, that's it. Hopefully that made sense. Again, let's just kind of review really quickly what we did because I know that was kind of a lot. So first thing I did was I wanted to determine what point I was looking at, right? What point? So I knew off the bat, based on what they gave us, I knew that the G inverse function was going to be of this form. It was going to pass through the point 2 something. Actually, I think I can point. Oh yeah, I can point. Okay, so I knew it was going to pass through the point. It was going to pass through the point 2 something. So that told me that the inverse function, right? Because whenever you'd have an inverse, you flip the x and the y. That the inverse function was going to pass through the point question mark 2 something 2. So then I said, where does G equal 2? And I went to my table and I said, right here, it equals 2. Where is that? Oh, at 1. So now I know that G passes through the point 1, 2, which means the inverse has to pass through the point 2, 1. That's how I found my point. And then for the inverse function, again, I kind of went over that a couple times. I found the slope of the pink line, and then I took the reciprocal of it to find the point, the slope of the red line. And then finally wrote it as a line. Okay, well, again, I know that was a bit of a tough one. Of course, if you have questions, please feel free to, ask them, things like that. We will have a Zoom meeting next week. I know with the Zoom meeting, I know that you have some multiple choice that you're going through. You have some more free responses that we have to look at. So there's a lot of stuff that might come up. So the next time I see you guys, I'll set up something for next week in terms of getting together and Zoom and you asking your questions. And of course, if you want to ask them, please do. If you want to send them to me ahead of time, that might be nice so that I can kind of prepare to answer those questions. Anyway, like always, please do not like, comment, and subscribe, and I will talk to you later.